I mean, share your screen now itself, and I will inform you when it's time for you to present.
Yeah, I will share my screen, sir.
Yeah, that's fine. Okay, ma'am, get ready. It's almost your turn now.
Okay, you tell me, sir, when you have to start. I will.
Okay, ma'am. Just give me a sec. Side. Okay, ma'am. You can start when you're ready.
Okay. So, Good morning, everyone, and thank you so much for such a wonderful introduction that you have given. And thank you for inviting me for the speaker of the day. So, it's my great privilege to share my perspective about this future approach of aerospace vehicle design. So, before jumping into this aircraft design, so you must know that what are the very basic concepts about this aerospace vehicle. So first, I will give the introduction about this flight vehicle and its component, control surfaces, and very basic movements of the aircraft. Then I will discuss the key factors required to design an aircraft and few case studies about the past, present, and the future aircraft till 2050 vision. So before we begin, that you must know what is meant by aerospace vehicle. So a vehicle which has a capability to fly in air within the atmosphere and outside the atmosphere. Now, here we can say that aircraft can be classified into various types. So it can be first classified into lighter than air and the heavier than air. So lighter than air says as kite, balloon, airships. Heavier than air can be classified in two forms, one with engine and without engine. Without engine, we say as a glider or the sailplane. With engine can be further classified as an airplane, rotor wing, or the ornithopter. So, in when we talk about this airplane is further classified as a landed plane. So, landed plane, the aircraft which can land on the land, not on the water or not or any other surfaces. That what we see most of the fighter aircrafts, most of the passenger aircrafts, they can land on the land surface, ground, earth. So amphibian is such kind of aircraft which can land either in water as well as having a capacity to land on the ground. Then seaplane, a very special type of plane which can both land on water. Okay. So here comes a rotor wing. Rotor wing further classified as a gyrocopter and the helicopter. So when we talk as a both having this helicopter, like both having the rotor blades. So these are the basic classifications of the aircrafts. Now we will see what are the flight vehicle parts. Now it is very important when we start begin to design, we must know what are the basic parts of an aircraft. So you can see this is a sample aircraft in my hand. So basically any aircraft having these four basic units. First is a wing surface, okay, where it helps to produce a lift, okay. Then comes the intake. Intake means engine. Here is the engine. So what this engine does helps to propel the aircraft move forward. So this is the function of the engine. Produce a thrust. Then tail. Tail, we have the two types of tail. Further two types. One is a vertical tail and one is a horizontal. This is a vertical tail. In the vertical tail, we have one control surface where the control surface is a radar. Okay, there is a vertical tail. Vertical tail, we have this is a vertical stabilizer, and these are the control surface. Using this control surface called elevator, we can make the movements of the aircraft. Then moving to the fuselage section. The entire section is the fuselage section, the body where the passengers can accommodate, where the luggage are dumped, or in case of the military aircrafts where the missiles are loaded into the fuselage section. So these are the basic units of any aircraft if we talk about the aircraft or the space vehicles. Now, it is very important to know what are the basic flight movements. Until and unless you know the basic flight movements, it is very difficult how this aircraft design begins. So basically in any aircraft, we have the three movements. First is a roll. Now roll is done by means of the aileron. The aileron is located on the wing surface. You can see here is a wing. We have this starboard and the port wing. So one we call as a right wing or left wing also. So in this way, we have in this particular path, we have this aileron. Now, with the help of aileron, what it does when it deflects downwards, a high pressure created, which helps to make it to roll, create a high lift. So another side, the aileron will be deflected upwards. So what happens due to the differential movement, it causes a rolling movement. So this movement is called as a rolling movement. Next, we have the pitching movement. Pitching movement is done by the elevator, which is located on the horizontal tail plane. So using this tail plane, what happens? Both the elevator what deflected downwards. When this is deflected downwards, the nose will be in the downward direction, because here it will create a lift and nose will go down. So this is how the pitching movement occurs, by vice versa, nose up and nose down, by controlling this the elevator. Then the last one, we have the yaw movement. Yaw movement is done by the control surface called radar, which is located on the vertical stabilizer. It can move on the left and right. So using the movement of this left and right direction, nose can also move to the right and the left side, the vice versa. If the radar is move on the right, the nose will also move on the right. If the radar is deflated on the left, the nose will also move on the left. So this movement, the left and right movement, is called as the yaw movement. So these are the basic movements of any flight. The first is a rolling, pitching, and yaw. Now we will come to the today's phase, that is what is the future, what is the future of the aerospace vehicle technologies now, and what will be in the beyond. Now, looking before that, you must know that for over 1,000 years, the man wanted to fly and to move from one point to another. So there have been some stories that there are some people who has been strapping bird-like wing structures in the stiffened cloth, and they kept put on themselves and attempt to fly from the tower. So this is how the initial 2000 years back it has been tried. Later in some BCs, what happens that the sky lantern has been developed, and the principle of the sky lantern is that based on the hot air balloon. So once the air gets heated, the density becomes lighter. So as it becomes lighter, it lifts off. So this is how the sky lantern has been developed. And back in this third century, um, this China and other people, they used to use this sky lantern to scare the enemy troops. So this is how has been developed, and as gradually in the 18th century, the balloon became a major rage in this evaluation, and also it helps to provide an understanding the relationship between this altitude and the atmosphere. Then again, using the methodological approach of the controllability of the aircraft, the Wright brothers also built and attempt to build power gliders in the year 1903. So after that, over a periods of time, it has been evolved from this cloth and wood biplane of 1920s. As you can see in the figure that they have been making wing structures using the wood structure and the cloth mounted over it. So gradually these evaluations have been keep on developing, and the date in 1930s it has been developed the first all metal single wing aircrafts in the 1930s. From there it has been developed to 100 passengers transport aircraft in 1950s, and gradually in the modern jet aircraft, and can see the modern, this is the Airbus 380, a double decker, and which has a capability to reach any point in the world in a very single day. So this is how the aircrafts of the 21st century may look, but fundamentally different and furthermore in the future. So all that inspirations begin from the watching birds. As you know, all like to watch birds, and many of you will look when we look into the birds, we feel to fly in the air. So all this concept is a biomimicry, or we can say the engineering in the nature style. So biomimicry is defined as the practice that learns from and mimics the strategy found in nature to solve the human design challenges. So this is how even NASA have been developed, has been inspired, and they have developed to the very next generation, but not as a blueprint, but as a biomimetic board. As you can see, this is a blended wing body, which is just look as similar as a bird. Even recently, a news came from Airbus that they have been developing an hybrid electric airliner, which is aiming to show the potential of use of biomimicry in the aviation design. You can see the winglets; it's almost looks similar as the feather of the birds. So today our main concern is the aerospace vehicle design, which states that any design is an integration of new new technologies and the systems with the current and advanced configuration. Now consider our national birds. All we know our national birds is eagle. Now eagle are being fully integrated or with all the systems that integrated in the real aircraft. As you can see, effective wing tips, propulsion system, survivability, extreme maneuvering, strong and lightweight, and even morphing wing. The wing can be flexibly folded. So looking into this aerospace space vehicle must aim to meet all the requirements which flies within and outside the atmosphere and must have all the following qualities. The first quality we need is the aerodynamics. Okay. Next comes the propulsion. Then structure and materials, flight control, avionics systems, and of course, we need to develop some advanced technologies. Now we will look each one by one very deeply how this each change in aerodynamics, propulsion, structure and materials, flight control system, avionics systems, and including advanced technologies can improve the aerospace vehicle design. Now, before beginning to any design, one must understand the following criteria, the following elements. First, what is the customer requirement or what is the demand or at present demand? That is very important to understand the demand. Without understanding the demand, without understanding the requirement, present requirement, we cannot step forward to any design. After that, in aerodynamics, the important factor comes as size and aesthetic. Size means in aircraft, we cannot make a very bulk thing. We must optimize the size and the shape, how it will look like. Maybe a design of a fuselage or the wing structure, engine locations, and many more. The more detail we will come in the upcoming slides. Then comes the functionality. Now, whatever we are using, we must think about the function, whether it is useful to bring the design into the picture or we must avoid it, or what are the weight factors, because weight is one of the prime concern in this aerospace vehicle design. Then comes a manufacture and the safety. Manufacture and the safety is another prime concern that we must see whatever which methodology we are following to manufacture the aircraft. So whether it is readily available in the market or whether it is not accessible in the market. So if I need to manufacture it separately, whether the cost will increase or not. This is also one of the biggest concern. So when we begin to design any aircraft, it is very important that one must know this following qualities. They must justify this following qualities before they began to design. The first comes with the requirement and then are the quality, size, aesthetic, function, manufacturing, safety. Safety, when we talk about the passengers, safety is another a big concern. Then, of course, the cost. We must reduce the cost of the aircraft. So, these are the factors. Now we will see how this all these factors creates a huge impact on this aerospace vehicle, aerodynamics, propulsion, structures, flight control systems, and advanced technologies. Now, we will start with the aerodynamics. Now, this aerodynamics, first we'll see what is aerodynamics. So, aerodynamics is the study of flow over any moving body. Okay, so here we concerned about this aerodynamics. We want to reduce the drag of the aircraft, because by reducing the drag, we must attain a better fuel economy. So what we can do, as you can see, when the flow moves over the bird, it has a streamlined pattern. So we must remember, when we design a aircraft, it must have a streamlined pattern. That is a one important factor. Second factor is a smooth surface. Again, by creating a smooth surface, we can help to resist, to avoid to create an air resistance into the surface to flow. So we must have a very smooth surface. So these two are the main criteria. And now the streamlined pattern is we can technically call as an airfoil shape. As you can see in the bird, when we define the structure, it is coming as an airfoil shape. So then what is the benefit of the airfoil shape? We will see. Using this, it helps to produce a lift. So when, as we increase the angle of attack of this airfoil, what happens? The bottom part of this airfoil, it creates a high pressure, and the top we have the low pressure. So always to bring an equilibrium, the move try to move from the high pressure to the low pressure. So naturally it pushes the object up. So it, due to this reason, it creates a lift. So this is how this has been evolved. The concept of this biomimicry has been evolved to inspire the aircraft's wing structure. And when the birds want to take off, birds want to land, they raise their wing. The same concept has been used in the aircraft wing system. And when we talk about the wing shape, is one of the main parameters that drive the aircraft performance to meet the aerodynamic optimization, or we can say aerodynamic shape optimization. Now this plays a great effort to design the wing. Now we can how we can do this aerodynamic shape optimization. There are so many tools at present. You can see here one example. This is from one of the research is going on. So this is a structure of a wing. They have split it in various sections, A to F section, and each section they have this different kind of airfoils. That means airfoil, I've said, it is one of the streamlined pattern, or it is a cross section of the wing. So each section having a different airfoil, and they are seeing the pressure coefficient in the top and the bottom of the surface when the flow at certain level. So they have used several optimizing parameters, and they have brought the result that it is almost going same. So this is how the aerodynamic shape optimization is done before they really manufacture the wing. Now, before you start designing the wing, you must know the what is the flight speed. Now, the flight speed can be defined in aeronautics by means of Mach number. So when we talk this Mach number is the speed of object by the speed of sound. Here the speed of object means it's a flight vehicle, speed of flight vehicle, the aircrafts, and speed of sound is generally as 340 meter per second. So this is how we define the Mach number. Now based on this Mach number, the flow has been subcategorized in subsonic, supersonic, transonic, and the hypersonic. Now, supersonic, when we talk about that, when the Mach number is less than 1. Subsonic is Mach number less than 1. Supersonic means when the Mach number is greater than 1. Sonic, when both the speed of the vehicle and the speed of the sound is same, we call as a sonic speed. Then transonic means it is a transition between the subsonic and the supersonic, which ranges between this 0.8 Mach number to 1.2 of Mach number. So this category comes under the transonic. Hypersonic means when the Mach number is more than Mach 5. So this is how we subcategorize, and based on this category, we need to optimize the structure or the design of this vehicle. That is a prime concern in this designing of the aerodynamics parameters. So if now here I want to give an example of the subsonic. When the Mach number is less than 1. So now I want to design, if anybody want to design of 100 passengers aircraft. Now, this is the design criteria of a 100 passengers aircraft. The flight must move in the region of subsonic. These are two criteria from the customers or the requirement, design requirement. So you can design in so many varieties. You can see there are four types of design at display based on various location of the wing. Here you can see the first, it is in the near the tail section. The tail, it is a inverted V shape. Then wing is a low wing. Nose cone is very sharp. Then second one, here it is a bottom part is flat. This is a conical one. And here we have three engines. Tail is a cruciform tail configuration. There are a lot many difference in the the four designs. So based on your aerodynamic performance, aerodynamic optimization, you must bring to a conclusion which design will be beneficial for it by keeping in mind the shape, size, function, manufacturing, safety, and also the cost. All these constraints must satisfy. Now this optimization can be further done. For an example, now, here I've given that is a much difference in when you design a subsonic and the supersonic. Now, what is the difference in the subsonic and supersonic? Subsonic, when the speed is greater than 1. Supersonic, when the Mach number is, this is less than 1, this is greater than 1. Now, you can see this is one passenger aircraft. This side, in the left side, you can see the right hand side, it's a one of the fighter aircraft. Both are not as per the scale. Both the figure is not as per the scale. Now when both the vehicles are submerged in the flow, right, in the flow is moving over this aircrafts, you can see that here it is moving smoothly, but here you can see in the fighter there is some divergence occurring. Now what happens when in case of fighter, you can see the nose cone is also very sharp here, but here it is kind blunt. Now these are the such features we need to constrain or keep in remember when we design any vehicle structure by considering the aerodynamics. Now, why it is so? Now, when the air is flowing over the subsonic aircraft, okay, so subsonic means when the Mach number is less than 1, it is moving smoothly. But once we are using or designing any aircraft which is flying at supersonic, we have a conical shape. That conical shape means why? Because if we are using a blunt surface like this subsonic aircraft, it will create a bow shock wave. Okay, it will create a detached bow shock wave, and in this bow shock wave what it happens that it creates a heavy pressure difference in front of the structure, and due to this pressure build up, it can also cause a structural damage. And if it causes structural damage, obviously the aircraft is no longer stable. It can lead to an fatal and accident. So keeping all this constraint in this mind, so when we are designing for an supersonic aircraft or supersonic speed in vehicles, we must have a sharp leading edge or sharp edge in the all this leading edge. And also when the flow moving along it, it creates an attached shock wave. So these are the constraints we must clearly remember the concepts before we develop any aircraft. Now moving to the next was that we are having lot many different types. You can see the MiG is one of the fighter aircrafts, which is also supersonic flights. You can see the sharp leading edge. This is an cargo aircraft where it can helps to carry helps for transportations of large vehicles. So this is one of the like You can see the configuration is different. This is a high wing configuration. Then again, moving to the large passenger aircraft, that is a Boeing 787, you can see again their configurations varies because each of these aircrafts having different configurations, different requirements, different purposes, and also different speed range. So based on its speed range, the factors also change. Then here another one of the amazing aircraft which NASA have been tested recently, Boeing 747, which this aircraft has a capability to carry a space shuttle. So when this aircraft will reach at the altitude of 15 kilometers near the tropopause of the atmosphere, this space shuttle will can take off from that, and due to that, their lot amount of fuel economy can be saved from the means of this. So lot many things are happening, and in future there are some future vehicles in upcoming. NASA and other vehicles has been tested that blended wing bodies you can see. Then this is the double wing. You can see these are the upcoming generation. It has been said by the NASA and the upcoming predictions. They said that upcoming generation we will have such kind of aircrafts. This will be obsoleted, and around blended body will be around 50 percentage growth will be there in upcoming 2050s. Now we will see how to do optimization. Now before we go for the optimization, there are two ways to do optimization. Now when you go for design, there is two ways. One is a measures of effectiveness and one is a measures of performance. So when we talk about the measures of effectiveness, that means we have to keep in mind about the customer's point of view. And when we talk about this measures of performance, we need to know the engineer's point of view. Now, how these two factors vary? Let's see. When we talk about the customer's point of view, you must know what is the amount of payload. Payload in the means what are the number of passengers will be traveling in the aircraft, what are the how much amount of weight will be carrying, like for the cargo aircraft, for missiles, how many missiles, what kind of fighter aircraft it will be, how many missiles will be carrying on that particular aircraft. So all those factors is one of the constraint, the payload weight. Then speed, as I've said, speed is one of the important criteria as a customer's point of view or on demand point of view. Then aesthetic. Of course, aesthetic means how it will be looking, how it will be appearing on the how the aircraft will look like. Of course, the look, the appearance and the look creates one of the major concern in the industries. Then technology, which technologies, what are the advanced technologies will be applicable in this customers. This will be at the customer's point of view. Now looking into this performance, gross weight, drag, power consumption, landing performance, and etc. Now, when we talk about this, now these all are directly or indirectly depending on the drag. If the gross weight is too much, that means the total weight of the aircraft is high, that means it will produce a drag. Okay, so more the drag, more the fuel consumption, lower the performance of the vehicle. So the aerodynamic drag or the aerodynamic design will be much effective. If we can reduce a drag, then it will also help to improve the efficiency and enhance the performance. So this is how you need to create an aerodynamic shaping, and aerodynamic shaping is a prime concern, prime important factors to design any aircraft. Now many people keep on ask that whether the blended body wing will be the future. Yes, of course, it will be the upcoming future. For the 50% of the aircraft will be of the blending body. Now how? That has a wonderful story behind this blended body. Do you know this blended body concept has been started in the year 1920s, which has been developed by the Nicolis. Then what happened? This the scientist Nicolis, he has been developed, has been tested, but finally what happened? When during the test he made an accident, so that has been gone. Then later again in 1940s again by another scientist from another industry, rather I can say that Miles M. 26 has been developed this project. But after testing, after developing, they didn't found much difference in this design. So again it has been obsoleted. Then again NASA have take over that thing in this 1990s. Then gradually they were keep on doing research and all, and they have developed a small prototype unmanned air vehicle, Boeing X-48. And they have designed a unmanned which can have a capacity, the payload, everything has been designed in such a way that around 450 to 800 passengers can accommodate in that particular aircraft. You can imagine, this is a very huge amount at a time. So they have also found, compared with the conventional one, around 20 percentage of the fuel savings are done. So this is a wonderful concept. As you can see, it is almost like a bird like structures. And even recently in this the news came up from the Airbus in 11th February, that they have been also demonstrated, they fundamentally demonstrated this blended body concept. And they have also declared that upcoming 2040s to 2050s, this blended wing body airlines will be implemented about 50 percentage. They have said that clearly. Not only this blended body, there are a lot many research are going on as a double bubble design, and also this is a V-shaped wing, you can see. Then again star based wing are used, and blended body. These are the upcoming futures of the aircraft. Now when an aircraft is flying at some altitude, it must undergo some kind of loadings on the structures, such as air loading, inertial loading, loading due to power plant. Power plant means engine, loading due to landing, takeoff, taxiing, and towing, jacking, or maybe even bird strike. So these are the following loadings can undergo by an aircraft. So based on that, it is very important for a designer to design the structure. So based on the research, and the researcher modified the structural design of the aircraft based on these applications. So, uh, as we know, when we talk about the structure of the aircraft, so structure of the aircraft consists of ribs. You can see the ribs, which gives the defined shape of an airfoil in every sections. Then we have the stringers, which is attaching from the root to the tip, the longitudinally. Okay, then we have a spars is mostly of I shape, C shapes, you can see here, these are the spars. So all those supports give the support and rigidity of the structure. Now these are the basic structures. Now in advanced research, they have found, they have modified the structures based on the type of aircraft. Now when we talk about this multi-rib wings, the multi-rib wing means the number of ribs will be more compared with the other factors, or the stringers or the spar. So multi-ribs are mostly used for the transport aircraft when we talk about passenger aircraft, cargo aircraft. Now this multi-spar means there will be a multiple amount of spars along to the root to the tip, where the number of ribs will be very less here. So this kind of structures will be highlighting for the high speed aircrafts and the fighter aircraft. The reason behind the high speed, because those high speeds undergo the shock wave, and shock wave is nothing but the high pressure acting on the surface or the material. So we must make the structure strengthened enough to resist such pressures. Then coming to the single spar wing. Now single spar wings are mostly used for the sailplane or the gliders. Single spar means there will be only one spar in this aircraft in the entire cross section of the ribs. So this is how, because we don't this kind of sailplane doesn't undergo much load or much impact. So this undergoes a single spar. See why this concern, and the researchers have developed because to only one reason, to reduce the weight. The once they reduce the weight, the fuel economy will go really high. So this is one of the reason. Amazing design has been done as a tubular spar design. This tubular spar designs are used for high altitude long endurance. High altitude means it can go more than 15 kilometer of the Earth's from the ground to sea level to the atmosphere. And long endurance means we use the term endurance in our aviation industry or in aeronautics. Endurance means time, the how much time it is flying in the air. So long endurance comes under the category when an aircraft can fly more than 24 hours, not less than that, more than 24 hours. That can be considered as a long endurance. So for such kind of aircrafts, we use this tubular spar, you can see. So these are the types of the high altitude long endurance aircraft. Mostly we use UAVs. These are the very commonly known Global Hawk and this Boeing Phantom. So these are also wide applications for surveillance. Some are for predicting the atmospheric properties and other factors. So yes. Then once we move out from these structures, then another important thing that human being has been aiming to discover another new and alteration of the design. Now, what is the alteration? Is called as when you see this concept has been developed by watching the birds. When birds want to move faster, they flap their wings, right? And the same principle has been implemented in the plane called as a wing morphing. Now, most of the modern aircrafts they use a fixed wing, as I've showed in the previous slides. Those are the categories of fixed wing. That means the angle cannot change, right? But in case of this morphing wing, what happens? The aircraft can have this multi-role capability. It can also sustain in the air for the longer time, even during flight. So scientists even have said that when the wing transform, it is easy to steer in the air, and it will fly much easier than the fixed wing. So there are a lot many research are going on. You can see even NASA has been pursuing the study today that also getting an inspiration from the biomimicry inspired aircrafts. So using that, so a lot many advanced materials are also used, which are to be very lightweight and more effective to build. Then as I've said, the weight is one of the prime concern for more decades that this aircraft builders or the designers who are working to build on the wings, if their main concern to design a strong and stiffer. This should be all those factors should be strong and also stiffer. And these are you can see almost looks like a bird-like structures, and they have just imagined the bird and they have implemented in the wing structure, and this will be the future. And they by how they're doing is by using the new smart materials. This smart materials has been embedded with the sensors and actuators, and this sensors, this you can see here, this sensors and actuators, how it works is they measure the pressures over this entire surface of the wing, and the signals actuates the how to respond the signal, and like how the feedback mechanism respond to each one another. There will be the tiny computations elements detect how this aircraft responds to the signals, and eventually they learn how to change the shape of the wing and optimize based on the flying conditions. So based on the sensors, they can optimize based on the flying conditions. So there are wide variety of opportunities and scope to work on. First is a composite materials, smart material, multifunctional materials, likewise shape memory alloys, then graphite based self-healing material, and now we are also going to use in the future as a bio-based self-healing material, because self-healing material will be implemented because fossil fuel resources going to be extinct, and oil price going to be high. The only thing will be the bio-based. Then another wonderful thing is the study effects of the meta materials on the aeroacoustic, like a radar absorbing material. Mostly this kind of implementations are used for the fighter aircrafts, as all of you know, as a stealth technology. So this is all the growth of this this our composite material. You can see here in this Airbus 350 XWB, they have used around 53 percentage of the composite. When we look around this Boeing 787, they have used almost 50%. And in nearing future, they are planning to build a few this composite around 70 percentage or even more. So this is the market strategy, US market strategy have given for an self-healing material for this 2014 to 2025. You can see that drastically it is rising the growth based on the compositions of the self-healing material. So you can understand what the future is coming up. So again, before in 20th centuries, they were studying about this fracture mechanics, that how the fracture begins. But today, that in 21st era, they are studying that how the self-healing mechanism gonna work, and more detail, more awaiting technologies are going to come. Okay, now after that this material structure is gone. Now the after wing we will come to the propulsion, which allows the body to move forward. That means the engine to integrate the health management systems. So in aerospace vehicle, engine can be further classified into two types. One is a air breathing engine, another is a non-air breathing engine. Air breathing means air breathing. By the name itself, you can say this air, when the system will be within the atmosphere. Non-air breathing will be the outside the atmosphere. This will be applicable outside the atmosphere, and air breathing will be within the atmosphere. Now, when we talk about non-air breathing, that means it comes to the rockets and all, so which can be of chemical, electrical, or nuclear for the future. But air breathing has been classified as a reciprocating engine, which we know as a piston engine, then turboprop, turbofan, turbojet, ramjet, scramjet. Now, looking this applications of these engines are need to consider based on the speed. Again, by directly or indirectly, it is coming to the speed. Now, how it happens? It also the speed we know that we always mention in aeronautics. We mention by means of Mach number, which defines the ratio between the speed of the flight by the speed of sound. So as you can see in this chart, that when we talk of the reciprocating engine, a piston engine, the flight speed should be of Mach 0.3 or within less than that. So beyond that, the aircraft performance won't be successful. Then as gradually we increase, let's move to the turboprop. Turboprop is almost like zero point 0.5 of Mach number. The zero point 0.5 of Mach number only, it will give the maximum efficiency. Now gradually moving to this turbofan. Turbofan can be of high bypass ratio, low bypass ratio. So this turbofan, sorry, this turbofan can be, as we increase, as we go nearing to the transonic speed, that is zero point 0.8, and so we use this turbofan. And beyond that, when we start using this fighter aircraft, when beyond Mach 2, okay, we use a turbojet. Then as we go, the increase the speed, afterburners are implemented. Ramjet is not starting with a zero, because it needs an external device to accelerate this ramjet. Similarly, the scramjet, the same, it needs an additional device to boost up its performance. Then comes the rocket. The rocket, you can see, it can reach more than Mach 6. So this is first when we design. It is, you must have a sound idea to know about the speed criteria and all. Now we will look into some of the principle of this turbojet. So what are the basic parts of a turbojet? Because most of the aircrafts we use this gas turbine engine, and these are the basic components of gas turbine engine: the inlet, compressor, combustion chamber, turbine, nozzle. Okay, so what happens from here? The air gets sucked, right? So air gets sucked. What happens after the air gets sucked? It moves to the compressor. When it is moving inside the compressor, the air get compressed. That means the pressure gets built up. The air get compressed. The pressure increases, and this pressurized area move to the combustion chamber. As it gradually moves to the combustion chamber, what happens in the combustion chamber? Similarly, like in the piston engine, the fuel injection takes place. There is a fuel injector. The fuel injection, that the compressed air and this fuel air get mixed up, and that hot air gases moves or expel out from the turbine and gradually expel out from the nozzle, and this nozzle helps to create a very high kinetic energy. Due to the formation of this kinetic energy, it forms a thrust, and that helps the aircraft to propel forward. But what happens, and this exhaust gas, when it expels out, most of the cases what happens, there are a lot many of unbound gases, and due to this unbound gas, it causes an pollution in the environment. Now again it comes to the point of the research, that how to improve the engine efficiency. Now once we may increase the engine's efficiency, we can consume the fuel, and we can, due to the consumption of fuel, we can lead to a better mixing of the this compressed air and the fuel in the combustion chamber. So there are a lot many ways that we can reduce the pollution, or we can take care of the environment. So these are the futures. They're looking a renewable energy source, that another way to reduce this carbon dioxide emission in the, by means of alternative fuel use in this gas turbine, or by means of electric propulsion, or by means of hybrid propulsion system. These are the categories that we can look into this aircraft design, by changing the fuel system, either by the electrical propulsion, the completely run by the batteries or the electrical system motors, or superconducting devices, or by hybrid. That means both by the electric and both by the this aviation fuel. So by that we can balance the environment. So there are a lot many research are going on. You can see that the hybrid electrical flight, as you can see, the Creakley, the first begin with the Creakley. Actually this aircraft has been developed as an turboprop aircraft before, and in the year 1997 around, right, by this Michael in the France. And later on he has changed that turboprop engine into this electrical engine, and he has successfully flown in this 2010. That is a Creakley. That is the first development of this hybrid electrical flight. Then gradually it has been increasing, and then Airbus also started to begin with a hybrid electrical propulsion, eFan 1.0. So gradually again further developments, and today in 2020 eFan X has been developed, and they said that eFan X is an disruptive technology. Now it is very unique thing. That's what is meant by the disruptive technology. It is such kind of technology which displays the established technology, that means which is in build in development, and which will bring a revolution in the industry, and which cannot be replaced by anyone else, and that will bring the superior to any other technology. So that is mean by disruptive technology, and that will be the upcoming vision of 2050s. And that is the eFan X has been developed, and achieving these goals is really a very challenging task. And particularly in 5050, they have 2050, they have declared that 50 percentage of the carbon footprint has to gradually go down. And with that, many people are working together, starting from the aircraft and aircraft manufacturers, airliners, airports, and anyone. And all the four pillars are the technologies for aircraft and the engine, as well as the sustainable fuel, operations infrastructure, and market-based measurements. All those factors are very great concern. And I would like to show you one more startup companies from Washington, like Zunum Aero. This name derived from this hummingbird, right? So they have developed this aircraft in, they have started in 2013 to 2018, their main concern was a 50-seater passenger aircraft, and they have driven this with completely electrical power, maybe hybrid electrical power. So this is what the future will look like. All those obsoleted which we are looking will be getting obsoleted. As you can see here, one of these superconducting things are used. Superconducting motor drives, fans are being used in the nacelle to drive to move forward. So, and in addition, this electric power, as you can see, it's also used to drive the internal systems of the aircraft, and so on. Right, and this is the strategies. I can see that what are the electrical power designs, what are the amount of power it has been developed. You can see Zunun have developed around two aircraft they have designed. One is a 4 to 5 megawatt, another one is a 15 megawatt, and both having the capacity of 50 seaters, and so and then we have this around 80 percentage of this carbon benefits can be seen in, not in this present, but they have been expecting to reduce the carbon footprints about 80 percentage from that particular design, maybe in upcoming 2035, and so. So this is that thing. Now coming to talk about the aerospace vehicle outside the atmosphere. Now outside the atmosphere, we cannot use these air breathing engines. We need to use the our aerospace vehicles like rockets and all like that. So recently, all of you have seen maybe the launch of a SpaceX launch, that Crew Dragon mission, where they have used the Falcon 9 rocket, and which this is a new development, which is the reusable launch vehicle, which will launch that Crew Dragon into the space, and after that it will automatically land back to those water bodies or the station where they have been navigated to. So this is what the renewable of the reusable launching systems will be the upcoming future. Even ISRO is working on it. Then, in addition, sooner or later, the electrical propulsion will take up. Already, this research are still going on, and about the microgravity. Yes, the concept about the microgravity, where NASA is experimentally also working, the staging of electrical propulsion system, about the interplanetary systems, everything is still working, still under research, and again noticing that the nuclear and electrical propulsion space system are being considered for the longer mission in the future. So this is also one of the thing. So here one more news came up recently about the development of these rocket motors of the future, breathes air like a jet engine. So it is almost like function like a scramjet, which is almost like two companies has been tried, and they have been tested, and which has been shown some result that it can really attain the speed of Mach 5. And if it happens, then it will be a great step towards the world's first air breathing engine, which can has a capability to accelerate from 0 to Mach 5. That means it can be self accelerated. It does not need any external source to launch. So these are the upcoming things, and again a few more new engine architectures has been done. This thing has been done by the Rolls Royce. Presently work is going on advanced and ultra fan engine. So what this Rolls Royce have done this thing, and they're expecting that 20 percentage of the reduction of fuel burn and CO2 emissions will be reduced, but in compare with another model of Rolls-Royce of Train 800. So they are comparing with the present model, the Train 800. So they have found 20 percentage there will be reduction in the fuel burn and emission of that. Then another Safran is also developing another design. Yes. So 1 minute. another design, which is the ultra high bypass ratio. Safran is designing. Then they have shows that minimum 25 percentage of this fuel burn and the CO2 emission will be again less in compare with the Rolls-Royce Trent 800 engine. So these are the huge work is going on, and soon and later this aircraft, this Safran, which we are making, the ultra high bypass ratio, which has a bypass ratio about 15, and also they have designed a very unique design, making using this lightweight composite material, and in addition, it can help to reduce a 5 to 10% of fuel efficiency, and they have optimized and found this kind of engines can be installed in Airbus 320 Neo family, and which is almost like a narrow body category, comes under the narrow body category. So you can understand why this this ultra high bypass ratio turbofan helps, because once we increase this factor, this bypass ratio, the overall efficiency will also increase, and if the efficiency increase, the specific fuel consumption of any engine will decrease. So this is how these are the all the advanced technologies that are coming up in the upcoming days. And when you begin to design an aircraft, selection of the proper engine is another one of the challenging tasks to design. And in addition, talking about the fuel consumption, not only the engine can help, also subsystems of the aircraft thing can also help to grow the industries. So this advance in aircraft systems can also help to reduce the fuel consumption considerably in this current aircraft configurations. So again, Safran has been developed electrical taxiing by Safran. So they have developed electrical taxiing to the ground when they from this aerodrome to the taxi before it takes off. At least they can use this electrical system. So using that, they can reduce a quite amount of environmental benefits out of it. So this is also one of the futures. And talking about this flight systems, yes. Now flight system, there are a lot many flight system, as I've already said how this flight, what are the flight control systems. Here we have the ailerons, we have an elevator, here is a radar. This is how we control the aircraft. These are the prime control surface of an aircraft. Now in upcoming days, there are lot many developments are coming, like Ele-1, Eleons are coming up, because some of the space shuttle they use the Ele-1 system. So apart from that, now we will look what are the advanced system, the growth of the flight control system. Now initially the flight control systems are done by this, the pilot here will be controlling the control stick or the joystick. The signal will be responded to the computers or the sensors, and it will go to this each control surface, and it will be actuating this control surface according to the motion given by this pilot. But this all are the mechanical system. Now mechanical system has been converted by the fly-by-wire system. Now mechanical has been replaced by the wire mechanism, which they have found by using the wires, they can reduce the weight of the aircraft. Now gradually what happens, again from the wire system, it has been moved to an fly-by optics. So fly-by optics, what happens again, compare with the wear system, when they go for the optic system, the optical fibers, they have found that again there is a huge change in the gross weight or the total weight of the aircraft. So the weight is a prime concern, as I've said. So using the change in the small change in the control system can affect the performance of the aircraft. So fly-by-wire has been converted into the fly-by optics using the optical fibers. So they have used a redundancy process. If one fiber gets failure, the another will be taking over it. So there will be lot many data bus avionics system into it. Now in upcoming future they have been working on, and even the patent has been already arrived about this fly-by wireless. Now there won't be any linkage, any connections uh, all will be done by this wireless. So you can understand using this wireless system huge amount of reduction in the weight of the aircraft, and once the weight of the aircraft gets lower, then the efficiency of the aircraft or the performance of the aircraft will automatically boost up. And apart from that, then one more disruptive technologies are coming up in this flight system, which we all of us were quite well known: artificial intelligence, we can call as AI. So this artificial intelligence are much more in the research field, and in upcoming society it will play a key role to do all the activities in the upcoming futures. Either we can talk as knowledge extraction. Knowledge extraction means we are extracting knowledge from the unstructured documents, or whatever the information we want to get. All these things will be coming from this knowledge extraction. Then comes and the computer vision. Computer vision will be about the transforming the image and the videos into object, and that will be taken or converted by means of deep learning and the decision making. Then come as a anomaly detection. Anomaly detection means that if there are some hidden patterns in the data, so that also it will that also it will helps to detect the thing by means of artificial intelligence. Then we come to this the conversational assistance. Conversational assistant means that the way of communication, that means the designer will make that the language interaction system. So whatever the language or this, they can interact, they can communicate, and they can build and develop, and they can keep on giving the inputs. Then comes a decision making. This brings an optimal solution for a very complex constraint problem. Decision making, it can take the decision by itself by means of artificial intelligence. And this autonomous flight, of course, this technology has been already implemented. This next generation aerospace vehicles brings a new capability to do that. All the things will have this autonomously, the part detections, automatically landing, tracing, everything will be done on based on this artificial technologies. And this will be in upcoming more than 2050s, all will be implemented. The 100% will be of artificial intelligence. So so as I can say, as a nutshell, it is very important before we developed a future airplane. So we must, when we design a passenger aircraft in future, we must increase the more number of passengers at a time. So at the same investment, we can travel more distance, and economically we can save the fuel. Cargo aircraft, we must have the effective transportation at a maximum endurance. So this is the future. Air taxing and air mobility transportation, which will be, and as I said, as AI, that is artificial intelligence, will be play a major role in that. Flexible movements from one place to another. And then electrical plane, as I've said, in upcoming 2040s, around 100% of the airplanes will be around electrical planes, for because this will be more focusing on the environmental issues, because we have to save the environment. Then military aircrafts, they're going to use these technologies like self-filling materials, stealth technology, and so on. So coming to as nutshell, as a concept of future, the concept of future will be balancing the functional and the performance, which will be constrained on this more sustainable, lightweight, fuel consuming, and also low manufacturing cost. All those four parameters will work hand in hand with the functional and the performance category, because eco-friendly aircraft is a prime concern in the upcoming future. And compared to today's aircraft, all the revolutionary aircraft concepts are being developed, and it plays an quite a considerable impact on the various aspects of operation. So this is what the growth of this 2020 to 2050s. Now I will show you what are the revolutionary technologies. In between this 2020 to 2050s, as I've shown, this Rolls-Royce and Safran have been developing more about the advanced turbofan. The growth of this turbofan will be around 20% implementation. Then laminar flow over a surface, that is another important concern, because if the drag produces, then again the fuel consumption will be more. So which we don't want. And then comes in upcoming within 2025 to 2030, we will have this wireless flight system where the implementation will be less, because it will take time to develop, because it will be growth will be around 1 to 3%. And but the ultra fan, which the Safran and the Rolls Royce are making, that there will be high growth of 25% within 2030s, within upcoming 10 years. So then again, within another next few years, we can see the new concept engine. There will be open rotor types that will be also be developed, and many industry like NASA has been already been tested, and okay, still more experimental work is going on. Soon they will implement a new engine core concept, as we have also seen that superconductive engines are also can be implemented in upcoming 2035. And these are the comes under this revolutionary technologies. After this 2030s and beyond that, we will have this, all the technologies will be implementing, or we can say revolutionary technologies. Before it was a evolutionary, and after this there will be a revolutionary. All the technologies will be applied and be going to a very huge hike. As you can see, the hybrid electrical aircraft in between the 2035 to 2040s, the 40% growth will be can be seen. And in upcoming 2045s, there will be 100% of fully electrical aircrafts will be visible. In addition, the morphine wing. As you can see, the still research is going on this morphine wing. But the implementation, the revolutionary will be acting from this year and so. And beyond that, this as I've mentioned clearly about this blended wing aircraft. So around the 50% implementations will be done in between these years, and double bubble aircraft will also be growing rapidly around 30%. So this is all about our future. These are the growth. There are a lot many opportunities that we can work on, and a lot many challenges for the blended wing design that can be done, because when that because a blended wing body can accommodate the large amount of passengers. So on the same time, it has very low burning fuel, and noise produced in the environment is very low. And as I can see, this cargo facilities will be there. um, as you can see, the cargo facilities are there. Cargo, huge amount of cargo volumes. So obviously cargo volume means the passenger capacity will be high, but the rules and regulations is another a concern, that acceptance has not been came from the FAA regulations. So another, if the blended body systems are implemented, the ground service infrastructure again need to be adapted, because the modding process, the jacking process need to be acted accordingly. Then there, because industrial in the industrial point of view, if you see, the it is creates a huge amount of investment in that. And one of the most challenging thing I would like to highlight here is the emergency evacuation, because emergency evacuation, it is the design of the blended wing is quite different than the conventional one what we can see. Because everybody will be having, when we see the aisle width, everybody will be having the window and one other side, but it is not the same case in the blended wing body. So evacuation, we need to look into it, and there are a lot many challenging factors that need to look, because safety is another one of the prime concern to while designing any aircraft. So these are the things I need to be look in the future. Then moving to the next, another thing is the electrical aircraft. Electrical aircraft, we can see that it is energy efficient, low noise, of course. It is much efficient. Of course, it will be starting with a low scale industry. But the challenging thing is that how they are going to store the battery, how long distance it can travel, where it will be, how the installation will be done in this airports and all. So this is one of the again a challenging factors. Then as I've said, the battery energy, power capacity, performance, it will be critical because it cannot endure the aircraft for the longer time, like which the Airbus or Boeing traveling for 15 hours. So same thing if have to be implemented in electrical aircraft, the size of the aircraft will go high, the weight of the aircraft will go high, then again it will be a critical point. So again, this is one of the challenges, huge challenge. And then again, certification of the battery safety, whether battery can sometimes explode. So again, it is one of the safety concern, give a prime concern, safety concern, you can say. Right. So all those challenges are there. Maybe sooner or later, the researchers and the scientists will come up with wonderful ideas and technology, and many more technologies are way to come in upcoming years. So here I would like to end my session. And if you have any further questions, please, I will ready to answer my best.
Thank you very much, ma'am.
Yes, sir. Thank you, sir.
Many questions are from the participants.
Okay,
I'll
sir.
just cut off some of the questions and I just ask only 5 to 6 questions to you.
Okay, sure.
The first question is from Arshdeep Singh.
Okay.
Why propeller engine is used instead of turbojet in Airbus?
Propeller is used, sir. In where? Sorry, sir. Can you repeat the question?
Yes, ma'am. Why propeller engine is used instead of turbojet in Airbus?
Sir, first of all, when we talk about the engine, right? So first we have to remember what is the speed of the aircraft, as I've mentioned here. So if the speed, whatever the Airbus have lot many categories. Now, there's most of the propeller engine, whether it is manufactured by Airbus or Boeing, whatever, the engine selection is mandatorily based on the speed. If the speed is ranging within this Mach 0.5, Mach means it is the ratio between the speed of the flight by the speed of sound. If it is less than 0.5 or so, then only we use the this propeller driven engine. And turboprop is used for the, if you look for the Airbus 380, right, this is also Airbus company, they have not used, they are using turbofan and turbojet engine, right? So it is all about the speed. So each, as I have mentioned here, the speed is one of the criteria. Based on the speed only we can design. It will vary. It is nothing like Airbus is making turboprop or turbojet. It is all about the matter of the design, matter of the speed.
Okay, thank you, ma'am. The second question is from Saumitra Das.
Okay, sir.
What is the scope of electrical engineering students in this field?
Okay. So, sir, there is a wide scope. I want to precise one thing. When we talk about this aeronautical or aerospace engineering, this is actually a multi-defined industry where we need to understand aeronautics as well as mechanical, electrical, computer science. There's a combination. If you are an aerospace, you must understand every domain clearly. If I want to talk about this electrical especially, there is a wonderful opportunities, or they can work on this flight avionics system or the flight systems. There are a lot many systems, as I've shown some slide about the flight control system. Before they were using fly by wire, now fly by optics, now advanced technologies are coming up by the fly by wireless. So these are the systems done by whom? By the electrical engineers, right, or the avionics engineer. So there is a wide scope. If they want, if they're interested, they can work on such field in this aerospace domain.
Sure, ma'am.
Yeah.
And the next question is from Prasad Belkundkar. Nowadays, which aircraft has the most efficient design and why is it that efficient?
Okay, that's a good question, but we cannot say which aircraft is too efficient or too good, or which we will be adaptable. So, but you have to understand one thing: when we design an aircraft or any vehicle, each having its own role or in own purposes. So if I talk about some of the cargo aircraft, right, so we can categorize the aircraft into cargo aircraft, military aircraft, fighter aircraft, then passenger aircraft. Now even I can classify the UAVs or drones, in fact. So we cannot say the which will be better. It is mainly based on the requirement and the purpose of that aircraft. Okay, so we cannot say which is more efficient. And of course, every developments are going on. Every aircraft, if every generation of the aircraft trying to make it better, and as I've shown that upcoming research is going on to develop this blended wing body. In this blended wing body, they are trying to build some superconducting devices through which it will propel to move forward. So there is no stagnant point to achievement or some it's good. Growth is growing. As I've shown, the growth is growing. Growth will be going till the end, right? So we cannot say which is more efficient in the point, but it does depend on this purposes. It should fruitful the purpose. That's the main thing. It is not about the efficient, but yes, as a designer, we have to look how we can make it a efficient one.
Okay. Yes, sir. Ah, okay, okay, okay. Okay, sir. Yes, sir. Yes, sir. One question. Only one question. We will just wind up that session. Ma'am, last question from Dinesh Babu.
Yes, sir.
What are the materials that can resist corrosions and have high hardness for spacecraft applications?
Right. So for high temperature materials, there are a lot many researches also going on, and at present they're using. So when we look about for the space shuttle vehicle, right? So space shuttle has a capability to re-enter the Earth's atmosphere. So when it is re-entering to the Earth's atmosphere, there is lot many thermal impacts are going on. So maybe you might be knowing about this Kalpana Chawla's incident. So the accident has, they were returning from this re-entry vehicle, and they has in front of the vehicle they use some kind, there are lot many materials actually to use such kind of things. One is a carbon, this composite material, composite tiles, then high temperature materials. And when we talk about the corrosion, especially any material we cannot directly use, we use an alloys, Nicolai alloys, or we can say about corrosion resistant, they must have a composition of the chromium. Chromium must be implemented in that particular alloy. So chromium has a capability to resist the corrosion. So likewise, there is ample of, even ample of high temperature sensors is also available. Research is going on the sensors when they use in the re-entry vehicles especially, right? So when the Mach number is more than 30, so you can understand the heat impact acting on this re-entry vehicle. So we cannot say precisely. There are a lot many aircraft which resist the high temperature. Titanium is there, nickel alloys are there. Okay, even in, if I talk about this, our uh, your rocket engine, in rocket engine thrust chamber, they use an oxygen free, this oxygen free, your high conductivity copper. So they use such kind of material. Depends on the place, depends on the type of aircraft, as I've said. It's all depends on the design. So there are ample of it. I think the answer is
Yes, ma'am.
clear
Yes,
to it.
ma'am.
Yeah.
Yeah, ma'am. Thank you for your information, ma'am.
Yeah.
Thank you very much, ma'am. Thank you.
Thank you so much, sir. Thank you. So can I leave the session?
Yes, ma'am. You can lead a session now.
Okay, thank you, sir, for inviting me, sir. Once again, thank you. Right?
Thank you, ma'am.
And thank you,
Thank you.
ma'am.
Thank you, thank you. I have to rush up because I'm having one more meeting. Okay, sir.
No problem. No problem, ma'am. Thank
Thank
you
you
very
so
much.
much, sir. Thank
Thank
you
you.
so much, sir.
So I request
Madam.
all the participants, thank you for your wonderful participation in this lecture. And for participation certificate, you can go to tems.wingsofaero.in. Okay, just type the URL tems.wingsofaero.in, and you can find the lecture certificate after successful login. Once you are login with the Gmail ID, just click Google. Okay, you can log in with Gmail ID, or if you want to log in with any other ID, you can register here also. Okay, right. So after successful login, you can find the lecture future approach of aerospace vehicle design, which will be in the front page also. Okay, so once if you click the front page, so if you are having any queries, type in the vehicle forum where we will send to the presenter, and presenter will give the feedback also, and lecture feedback, how the lecture was there and how we can improve our TEMSera platform. So if you suggest, we will act accordingly. Okay. So once you have submitted the forum and the feedback, you can get the certificate. Okay. So with this, we are ending our session. And one more thing, there was an upcoming webinar from NASA, Mr. George Salazar. He is a human computer uh, interface lead, technical lead, working at NASA Johnson Space Center. Okay, so the lecture topic was challenges of future space missions. So it is on 8th July 2020. So you can register over here itself. The same procedure for registration also. So with this, we are ending the session. Thank you for your participation. We will meet on